All right, up until this point, we've talked about how to calculate grams of a product. And whenever we do a calculation of grams of a product, how much product can be produced, that's in a perfect world. So if the world were perfect and we were to react so much reactant, we'll produce a certain amount of product. But the reality is the world is not perfect. And if we were to actually go through that chemical reaction, there will be some errors involved, whether that be errors with the system or just errors that are inherent with the way the chemical reaction is occurring. But what ends up happening is you do not produce all of what you say you should. For example, don't know if you guys have ever done this, if you are baking some cookies and you buy a tub of cookies or a roll of cookies, and it says you should be able to bake 12 cookies with this. Has it ever happened where you only were able to get 11 cookies? Because maybe you made the cookies a little bit too big or something. Well, that's obviously you're only getting 11 instead of 12, and so you're not getting the full yield of cookie. So that's kind of what it is. And so the theoretical yield, so when we talk about theoretical yield, the theoretical yield is the maximum amount of product that can be produced from a given amount of reactants. This, I like to call this is the perfect world. So this is the perfect world. Also, this is a calculated value. This is the calculated value. And so whenever we do any calculation, in fact, all of the calculations we've done up to this point are theoretical yields. Now we're going to talk about actual yield. The actual yield is the measured amount of product obtained from a chemical reaction. And so whenever you're doing an experiment and you perform that experiment, you perform that chemical reaction, what you actually get is the actual world, and I call this the actual world. So this is the actual world. So there's the perfect world and there's the actual world. This is a measured value. Usually this is a measured value. So it's like a measured value from a experiment or something like that. Then what we can do is we can actually calculate the efficiency of the reaction, so the efficiency of the process. And we can do that by calculating the percent yield. And the percent yield is a ratio of the actual yield and the theoretical yield. And the way you do that is you take the actual, you divide it by the theoretical, then you multiply it by 100, and that will end up giving you the percent yield. And that is the equation. And so this is really easy. So let's go ahead and talk about how we can do this. So when you're looking at a problem like this, it says methanol can be produced through the reaction of carbon monoxide and hydrogen gas in the presence of a catalyst. And so here is the chemical reaction. And so what it's saying is, it's giving us, it says 75 grams of this. 75 grams of this are reacted. And what ends up happening, it's saying that it produces this many grams of methanol. And it's asking for the percent yield. This right here is the actual yield. What it's saying is that this is how much was produced when we reacted 75 grams of carbon monoxide. And all you need to do to calculate the percent yield, that's what's asking for, percent yield, what we need, again, it's the actual divided by the theoretical times 100. The actual is a measured value, which is right here. The theoretical is the calculated value, and the calculated value is when we take our grams of carbon monoxide and we can go and calculate how many grams of methanol should have been produced. So essentially we're going from grams of A from carbon monoxide to grams of B. And so we can go ahead and set this up. And we have our grams of carbon monoxide. And we'll go from grams of carbon monoxide to moles of carbon monoxide. And then we're going to go moles of carbon monoxide to moles of CH3OH. And I'm going to erase this because it's getting in my way. And then we're going to go moles of CH3OH to grams of CH3OH. A 1 always goes in front of moles, except for when it's mole to mole. We use the coefficient in the balanced chemical equation, which happens to be a 1. The molar mass for this is 28, and the molar mass for this is going to be 12 plus 4 is 16 plus 16 is 32. And I'm using rounded numbers here. And so we can just type this in our calculator. And what I get when I type this in here is I get 85.7 grams of CH3OH. And again, this is the calculated value. This is how much the perfect world would produce. So if it were a perfect world, we would produce 85.7 grams. Again, the theoretical yield, you will always have to do a conversion, a stoichiometry conversion, to figure out the theoretical yield. And then the problem will give you the actual yield. So it's giving you the actual yield. And so now what we can do is take our actual yield, divided by our theoretical times 100. And so we end up with the 68.4 divided by the 85.7 multiplied by 100. And that will give us our percent yield. So we just type this in our calculator. And you end up getting a 79.8% yield. And so this chemical reaction, it's got a 79.8% yield. Now, what I'll say is this type of problem is extremely relevant in many things in the world. And so you can go to a bakery, you can go to you know, a chemical engineering firm, and you'll be able to see this sort of thing. So like a bakery will buy a certain amount of flour to make a certain amount of cakes, and let's say they buy a certain amount of flour to make 100 cakes, but then they see they only make 95 cakes. That's something that messes with their profit margin, and so, you know, this concept is used heavily in the real world. All right, so let's go ahead and do this next one. Obviously, the first thing we need to do is balance this by putting a 3 here, a 3 here, and a 2 here. And so this problem is a little bit different because this is not asking to calculate the percent yield. Instead, it gives us the percent yield and tells us to calculate what would we actually produce. Okay, so in this situation, again, it's actual over theoretical times 100 to give you the percent yield. Except this time, it's giving us the percent yield, which is this. And what we need to do is calculate the theoretical yield by doing a conversion, and then we can solve for how much is actually produced. And so again, this is in the real world, so maybe a baker knows that they're only going to use they're only going to have a 95% yield, and so they have to order flour accordingly. And so let's go ahead and do this particular problem. So we get 1.85 grams of aluminum. And it's asking how much copper will be produced. So it's asking for that. So it's giving us grams of aluminum, asking for the copper. And we're going to go from grams of aluminum to moles of aluminum. Then what we're going to do is go from moles of aluminum to moles of copper. And then we're going to go moles of copper to grams of copper. A 1 always goes in front of moles, except for when it's mole to mole, we use the mole to mole conversion here, because we know 2 moles of aluminum will produce 3 moles of copper. We use the molar masses here, which this is about 27, and then this is 63.5 about. Okay, then we type this in our calculator. And you end up getting 6.53 grams of copper. Now again, whenever you do this, this here is the perfect world. If the world were perfect, we would get that as our outcome. But we don't live in a perfect world. This world is only 56.6% perfect. And so that means that only 56.6% of this will be produced. Now, this is the theoretical yield, and you can totally plug it into that, but instead, what you can do is, remember from math class how you find the percentage of something. So how do we find 56.6% of that? Well, we take this and we just multiply it by its percentage in decimal form. So this is definitely something you learned in math. So how do we find 56% of this? We multiply it by the percentage in decimal form, and that will actually give us the answer. If you want to, though, you can totally plug it into that equation, and you'll see it mathematically is exactly the same. So what this reaction will do is produce this many grams of copper, and this is the answer here. So just a quick recap here. In this first problem, we were given how much we actually produced, and we were asked to calculate the percent yield. So you take what's actually produced, you divide it by what you can theoretically produce, like the maximum amount, multiplied by 100. This one, we were asked to calculate, well, how much will we actually produce if we know it's only going to be 56.6% efficient. So this is not too bad. This concept's not too bad. Definitely look at the guided practice problems, or I'm sorry, the independent practice problems, and check the key for that. Make sure that you're putting in the practice because it's very important. So go ahead and come to class with questions. Have a great day, and I'll see you in class.